webinar in which I will give you some insights into the world of pollen analysis methods. You will first get a short introduction and overview about the most commonly used methods. Then I will show you in some examples limitations, drawbacks, advantages and disadvantages of these technologies. And in the end, showing you some data that we obtained by comparing impedance flow cytometry with germination analysis or with staining analysis, and draw some conclusion out of this data. Due to the limited time, of course, I cannot enter into all topics. I can just scratch the surface, but I hope that we will have the opportunity to ask your questions in the Q&A section that is just after the webinar. So let's start. When I started preparing this webinar, actually I asked myself first, what would be the ideal in vitro pollen analysis method I would expect? First of all, I would want to have a very accurate method that I can trust in. Then the analysis must be speedy and deliver quick results because my pollen might not be stable at room temperature. Also very important is how much information I can gather out from a germination or from a pollen analysis measurement in general. So whether you just get viability, you get counting, or you can combine all the measurements together possibly. Moreover, I would really be happy to have a very robust analysis in place that is not easily affected by factors like temperature, like buffer conditions, like hardware setups, or even operator bias. And finally, it would be great if I could have an analysis using a standardized protocol that delivers the same result all over the world, operator independent. Before looking at those parameters a little bit closer, I would like to give you a short overview about in vitro pollen analysis. And as was previously shown in Philip's webinar, we distinguish basically 4 different main pollen applications. There is, on the one hand, pollen viability determination, but also pollen quantification, pollen ploidy analysis, as well as micropore stages analysis. These different criteria are addressed to determine, or there are different test criteria to determine these parameters. For the viability, most important, the membrane integrity is interrogated, or the intracellular cytoplasmic activity. Another widely used method is the germination method. I will talk a little bit about this a little bit later. And some people still do some, we say, quantifying the seed set by after artificial pollination. Other methods, of course, or test criteria are pollen size and pollen count when you're looking at the quantification and ploidy level, and also the nuclei shape or number, or even microspore size and their electrical membrane characteristics if you have a look at the developmental stages. We see 3 different methods that are commonly used for addressing these test criteria. The normal ones are the staining procedure that need subsequent microscopic or fluorescence microscopic quantification. There are some counting applications that you have just to count with your microscope, for example, in vitro germination, or using a Coulter counter for the quantification of pollen shedding, for example. And there we have the impedance flow cytometry, which basically covers all the spectrum of the application shown on the left. I will focus my presentation and my webinar on the viability application and with the in vitro germination, but not with the seed set. All these aspects, seed set, pollen size, ploidy, and so on, will be discussed in the later seminars of tomorrow and after tomorrow by our group of Silvan, Georg, Federica, and Grit. I really recommend you to attend those webinars. So let's have a look first at some staining methods. In this first example, you see 2 classical staining methods, the FDA staining here, and the TTC staining. These techniques are based on the fact that these molecules can penetrate into viable cells as well as into dead cells, but only in the viable cells they are modified to fluorescence molecules like fluorescein in the case of FDA, or to red-colored formazan by a dehydrogenase for TTC. These activities are not present in dead cells, and this is why you basically count the living cells using this technology. A weakness of the FDA staining is that fluorescein can leak out of the cell, leading to a fluorescence fading, which on its side makes it quite difficult for the operator to have a good readout. TTC on its side has the drawback of requiring quite a lot of time, incubation time, before you can count the cells, and sometimes tends to overestimation. The alternative to the intracellular activity is the interrogation of the membrane integrity. This is often done using different dyes like trypan blue or propidium iodide, which are retained from viable cells but can penetrate easily into dead cells. Trypan blue is there and thereby accumulated into the cells, coloring the cell in blue, while propidium iodide intercalates with the DNA of the cell nuclei and enhances its fluorescence by a large factor. The drawback of trypan blue is basically that it's also entering viable cells if you wait too long before you are doing the counting, and this way leading to overestimation of dead cells. Propidium iodide on its side is sometimes interacting, as shown in this confocal microscopy picture, with the cell wall of pollen, and this makes it sometimes more difficult to discriminate dead cells from viable cells. So, in summary, using staining techniques bears some limitations. Staining protocols can be labor intensive due to complex sample preparation, but also due to cumbersome data analysis. For the FDA staining, as it's shown here, for example, you need to count twice your area in the bright field as well as in the fluorescence mode. This lowers the throughput of your method. And as a consequence, of course, this method normally analyzes only a few hundred of cells to have a certain throughput. In addition, you must also consider that there are some staining ambiguities, as shown here in this example here with FDA. So what would you do if you had those cells that are very faint stained with FDA? Would you count them as viable or as dead cells? So there is a large operator bias factor as well. And one shouldn't forget that many of those dyes don't work for all the pollen that you possibly like to analyze. Impedance flow cytometry is also taking advantage of the membrane integrity for discriminating dead cells from viable cells. Philip has already explained the measurement principles in the previous webinar, so I won't go into the detail. I will just make this, let's say, complex story short by telling that we are analyzing the cells in a microfluidic chip at high speed. So the cells are flowing at high speed through this microfluidic chip, and they are crossed by an alternate current, high frequency current, which crosses the cell such that in a dead cell that has a compromised cell membrane, it passes basically through the cell, while for a viable cell, the current is somehow retained, which leads to a different, we call it impedance signal, that then are displayed on a amplitude phase diagram, which we call density plot. And in this density plot, we can discriminate among different factors like viability, like pollen size, as well as total count. As mentioned, look at this webinar if you want to know more details about this analysis technique. Important to know is basically that it's a label-free technique. There is a very simple and quick sample preparation step, and you can count as many as 1,000 cells per second, which gives you a very high statistic power, because in half a minute you are counted several thousands of cells, and this is of really highly statistical relevance. We have almost tested, or we have already tested more than 200 pollen species with this technique, and it worked quite well. But it must also be mentioned that impedance flow cytometry has been validated for all for any kind of cells, also for yeast, for bacteria, fungal spores, animal and human cells too. Now we'll want to switch to germination, to some frequently asked questions by our customers. But before I go into that, I wanted to invite you to start or continue asking your questions on our Q&A chat, because this way we can answer them, let's say, more just after our webinar. So let's have a look at the pollen analysis, and I'd like to start with, as mentioned, some questions here that we were faced to in the last couple of years when dealing with our customers. One question is, for example, the viability in vitro and in vitro germination allow or show at least a good correlation for fresh pollen, but there is a big gap if you are looking at the stored pollen. So what happens here? Or another question is, why do the published germination media don't work for my pollen samples? Or even, why do I still get seed set if the pollen does not germinate? A more general question could be, how similar or different are in vitro and in vivo germination conditions? Does it make sense to do in vitro germination if the in vivo germination conditions are completely different? Another question that I would actually ask you directly is, how confident are you about your in vitro germination assay? In a recent study published by the group of Manuela Nagler from the IPK in Germany, they basically compared different in vitro viability analysis, in vitro pollen analysis on wheat pollen, on different lines of wheat pollen. I don't want to go too deep into the details of this analysis, but what I want to show and what actually took my attention was the fact that the in vitro germination values were much lower than the FDA staining or IFC analysis, which showed pretty much the same results. So my question is, would you, if you had these results, or what is the gap that you would accept between in vitro germination and your viability assay, and what, let's say, and which method would you trust more? Having a closer look at the germination assays basically reveals that there are several factors affecting the germination result by really significantly. For example, temperature, matrix time. I don't want to go into these details. You are probably aware of these ones. I would like just to focus your attention on two factors, which are statistics on the one hand and germination media on the other hand. Let's start with statistics. And this applies, by the way, also for the staining methods. One thing that one has to know is basically that the statistical error applies basically to any kind of measurement, and it mainly depends on the number of cells being counted. On the left graph here, you have the situation in which 50% of the population has viable cells. If you pick up now just 10, 100, 1,000 or 10,000 cells of this pool, you will end up with a relative standard deviation that is completely different. For 10 cells, you get an error of around 16%. For 100 cells, you are going down to 5%. At 1,000 cells, you have less than 2%. If you count 10,000 cells, you are around at 0.5%. What does it mean actually? It means that if you are accepting an error of 5% by counting just 100 cells, you have to consider that there is a quite nice probability that you are way off your right value of 50 by a factor of 10 or 20%. So if you compare different pollen analysis methods, have a look at your number of counted cells and the possibility of, or the size your statistical error can get. In this slide, we show one of our first validation experiments. Here we compared FDA PI staining with IFC for fresh pepper pollen. Our goal was basically to reduce the statistical error by counting around 1,000 cells per data point, which was done using an imaging software and counting 60 pictures per data point. That took quite a while, so the experiment took around 10 hours. As compared to the staining, we did the same with IFC. Here we counted 5,000 to 10,000 cells, did duplicates, and had finished the experiment after around 20 minutes. What was most surprising was the fact that even though we counted 1,000 cells per data point, we still got a standard deviation of around 10%, which we didn't expect, as I have shown in the former slide. So we were expecting a little bit smaller. And this actually might be or might come from other errors like the color or the staining ambiguity that I mentioned before. In any case, these two methods show very nice correlations if they are done well, as you can see from this slide. And when you had 80% viability through IFC, you got the same value with the staining method. In a quite recent validation experiment, we did a germination versus IFC validation. And this was done because some of our customers complained that our impedance value or IFC viabilities were higher than their germination values with stored pollen. Excuse me. So we started also some experimentation in our lab and started initially with the Brubaker quark buffer, which basically confirmed what we got from the information we got from our customer. As you can see here, we depict in this graph pollen germination versus pollen viability. Even though we have a very nice correlation, we still see that, for example, for a viable sample by IFC of 80%, we just get around 35% of pollen germination. So there is a gap of basically 45%, which we couldn't accept actually. And that's why we were doing some more research and developing new buffers, and ended up with a buffer that we call D0 that showed a pretty nice correlation as well. But this time you got for 80% of viable pollen by IFC, almost, or let's say 75% viability or germination using this buffer. And this was a clear indication that the germination media can affect dramatically your result. By the way, if you have a look at the data displayed here, you also see that the time it takes for doing an impedance analysis or a germination analysis is quite different. For a set of 10 analyses, you need more or less 1 hour more if you are doing pollen germination. And of course, the precision is also by a factor of 10 smaller if you are using germination instead of viability by IFC. We repeat these experiments with corn pollen just to check whether this was also a problem. And in fact, we had issues when we were using the buffers indicated in the literature. Only after our own development of buffers mentioned here, D5 and D6, we got pretty nice correlations and also quite a good ratio between pollen viability and pollen germination. Here, for example, with this slope, around 67% of pollen that was judged as viable by IFC germinated, and using the next one, the D6, almost 95% germinated. So we could basically reproduce the same results as we have done with pollen. And again, we had significant savings in time measuring it by IFC as compared to the values done with pollen germination. So to summarize a little bit these results, and picking up the expectation I mentioned in the beginning of the webinar, I would definitely say that I wouldn't really trust in the germination assay unless I had a good validation for it, either by IFC or, for example, with a staining method. In any case, I would be quite skeptical if I saw a gap more than 20%. I have shown here some examples of nice correlations between IFC and staining, as well as for IFC and germination. Nevertheless, I would definitely say that there are some serious limitations in the staining and germination methods. IFC in this regard, mainly looking at the parameters like accuracy, repeatability, throughput, time to result, or even labor time, and last but not least, also the robustness of the system, is a much more powerful tool than in vitro pollen analysis by germination or by staining methods. Therefore, I see IFC in future as a true candidate for providing standardized analysis for pollen viability or any other pollen analysis, in vitro pollen analysis methods. So with that, I would like to end the webinar. I hope that you got a glance about the world of in vitro pollen analysis. Thank you very much for your attention. And of course, Grit and I are really now looking forward to answering your questions. Thanks again, and bye-bye.
Thank you, Marco, for this really interesting presentation. And then there came up already a lot of questions, and I think we will try to answer the most of them. There came in a general question, is there a correlation between lab testing, pollen viability, and pollen viability during the pollination?
Again, I didn't understand your first part, excuse me.
Is there a correlation between lab testing pollen viability and pollen viability during pollination? So I think if it's done on the manual pollination, I think we can always check the sample between.
Yes, I mean, the question is always when do you do pollination? I mean, is it artificial pollination, or is it a pollination that you are expecting from, let's say, self-pollination? Because the pollen is collected somewhere or used for artificial pollination, or is it pollen that you just check in the field? So for me, it's not clear what let's say, in which direction it goes actually.
I think it's so that if they want to apply the pollen so that they can check it. I think with our device it's possible also to check it on the field.
Sure, I mean, it's a portable device in a way, so you can, if there is the risk that the pollen is dying on the way in the lab, you should for sure try to measure it in the field, which is possible with our device.
There came up a lot of questions about germination. So the one is, can you ensure that every pollen grain which is viable can also germinate?
This is a great question. I cannot ensure it, but I think that for me it's clear, viability is always a little bit higher than germination. But if I had a difference of, as mentioned, more than 20%, I would start asking or questioning the result of the germination.
There was another question to the technology at all. If we have tested plant protoplast for viability, and I can just answer yes, we have also measured this plant protoplast, and we can also check this for the viability. Exactly,
and of course, you can reuse the cells after measurement. This can be helpful for protoplast, for example.
There came up another question about if you have to treat the pollen somehow before measuring them?
Well, you have just to put it in the right buffer and sometimes filter it. It depends on the sample quality, but I would say just use the right buffer and filter it with the appropriate filter that we provide normally, and that's basically all you have to do.
There came just up some other questions to germination. If we tested germination in separate batches, or if we recovered the sample from the measurement with the impedance measurement and put it then on the media.
No, let's put it this way. We use the same batches normally, but as the germination media and the measurement media that we use for the analysis are in most cases different, it's quite difficult to basically centrifuge them and resuspend them in the other media for doing the analysis. So we just use the same batch, dry pollen, and put it one time on our buffer, on the measurement buffer, and on the other hand on the germination buffer.
There came up a general question if it's possible to purchase our germination buffers.
To what?
To buy them.
Okay. Well, you see, this is a interesting question. I can understand that people would like to use it, but for me, it's more, I just told you in a way that doing germination is so cumbersome as compared to IFC on the one hand. And on the other hand, we have also to consider that there are some line dependencies of these buffers. So what works with one line might not work that perfectly with another line. So we wouldn't actually sell these buffers. We rather use it for validation purposes, just to make sure that our technology is doing the right thing.
There came up some questions about the comparison of the different methods. Which kind of comparison would you make? Would you go for staining or would you go for germination if you compare these methods with our one?
Well, it's a really good question. I guess that I mentioned it. There is basically no standardized a standardized method right now. So you cannot just in a way rely on a standardized method. So if you would like to check IFC or germination with IFC or with staining, you really must figure out that you have the right setup and the right method and dyes that you are using. I wouldn't prefer germination to staining or to our device. It's just the only thing that makes it different is that you just save a lot of time using our device, while if you compare germination with staining, it's really hard work and not really promising, let's say, what you are really looking for.
There still come up a lot of questions about germination. One is, can we measure pollen vigor? Can we see the vigor by the pollen tube length? Also it's visible to see with germination, the pollen tube length and the time how it germinates, if it's possible also to see this with impedance.
Well, we have some indication, at least for many other cell types, not only for pollen, that the phase value can have a certain information, but drive or assign this information to a vigor, I would be quite, let's say, critical to that or skeptical to that. I mean, it was shown on one of my slides as well. If you just use the wrong, I mean, vigor is sometimes measured by measuring how fast the pollen tube grows in the germination media. But if you have a good or bad germination media, you have different speeds there as well. So is the vigor different if you choose a different germination media? So that's why I would say I couldn't say that our technology would also discriminate vigor, but I would say that if our technology says that you have 50% viability, you should, if you don't have, let's say, different maturation level of the cells, you should get around 40 to 50% of germination if you have the right germination protocol.
Okay, thank you, Marco. There was one question if we can measure with the EFC germinated pollen.
Yeah, sure, I did it already. You have just to take care of one thing. If the pollen tube is too long, you might have some issues clogging the microfluidic channel, but it is possible, and you see differences. So it's a good idea. We had it as well, and we did some experimentation there too. It works.
There came up some questions about the price. Is EFC more expensive than staining method or than germination?
Very good question. I guess one has to, let's say, differentiate among the three methods. If you compare the hardware requirements, for example, IFC and staining might be similar. For example, if you're using image software analysis, or if you are using fluorescence microscopes, which are much more expensive than normal microscopes. For the germination, in vitro germination, you need for sure less hardware and less, let's say, investment costs in terms of instruments. But as I have shown, you have a hell of a lot more work. And this depends a little bit on your working costs. But if you just look at 100 samples, you just spend 10 hours more using germination instead of IFC. And then you can calculate how long it takes that you have your return on investment.
There came up some general questions about the measurement. How many cells do I have to measure to be precise enough? This
is a question that I would really look at the curve I've shown with the errors, with the statistical errors. We say, I would answer the question in telling how big or when are you feeling sure enough with your error that you have. So we have seen 1,000 cells have a statistical error of about 2%. If this is good enough for you, then 1,000 cells would be okay. But if you need more precise analysis, you need to count more. And again, it's just a statistical error. You have also to check the other errors that you are having in the system, be it staining ambiguities, operator bias, for example, also different hardware, like different microscopes. This can change the value, let's say, significantly.
So perhaps we have time for a last question. One was, how many measurements can I perform in one day? You already talked a little bit about, but...
Using IFC, you mean?
Yes.
Well, experienced people are, I would say, normally analyzing. I mean, you are experienced, great. How many are you doing? You can easily do 200, I know, but I would say yes. From 50 to 150, everything is possible, and you can hire grit, and then you can do 200.
Okay, good.
Around the number you can do if you are preparing your experiment accordingly.
I think here it's important that you also test how many you can do in advance, that you look for buffer stability. If you have to prepare the samples, how you have to prepare. But this you also will see in the other sessions, as well as in my session and Philip's session on Thursday.
Okay, and of course you can, if you need the time for doing something else, and your measurement is stable enough, also use a auto sampler that it's basically a walk-away solution that you can focus on other things as well.
Okay, thank you very much, Marco, for your interesting presentation, and Grit as well for taking care of all the questions. I can see that there are still questions coming in. Unfortunately, we have to end this session here. All of you who would go into detail, discuss your questions, please don't hesitate to contact us. We're happy to receive your questions at info@amphasys.com, or you find the detailed contact information of our experts on the registration page of every individual session, if you would like to contact them directly. I would like to thank all of you in our audience today for attending this session, also the 2 sessions before. It was the first day of our virtual Amphacademy today, and we are very excited and almost a little overwhelmed to see how many people from all around the world have joined us for these 3 sessions. The next 2 days are offering even more sessions. Tomorrow we will go into details of specific pollen. So at 2 o'clock we will start with a customer success story. Martin Janssen from the Radboud University will talk about a large field project he was working on and where he has used our technology for thermotolerance screening of tomato pollen. The next session is a Solanaceae pollen analysis, very specific, by Silvan Kaufmann, our Solanaceae pollen expert. And then to sum up, tomorrow there will be a session on wheat and other small grain cereal pollen analysis. So stay tuned and register if you would like to attend those sessions. It's still possible. They're all free, as you know. And even though if you don't have the chance to participate, you will receive a link to every recorded session where you can watch the content on demand. Okay, so thank you very much for your attention, and I wish you all a very nice and pleasant rest of your day. As leaving, please take a little time to answer the 3 questions of our survey. It will help us to improve future sessions like this one if we get your feedback. So thank you very much, and I hope to be welcoming you soon tomorrow in one of the next sessions. Have a nice day. Bye.
Thank you. Bye-bye.
Bye.